Here comes a testing talk. Hello everybody, I'm Michał.
I'm Maria.
And we work at CallStack as software engineers, and we couldn't be happier about speaking at this conference this year.
Let's start with how testing of React Native components looked before 2018. We essentially had two ways for doing so, React Test Renderer and Enzyme. React Test Renderer allows us to transform React elements into plain JavaScript objects and perform queries on it. It doesn't use DOM to do so. Its API allows for traversing React component. Paired with Jest, it's easy to generate snapshots out of the output. Let's see it in action. Here is an error message component, which requires title property and renders two elements, message icon and text. Quite straightforward, so let's go to the test. First test is a snapshot. We use create function to render an error message component with set.prop title and convert it into JSON. On the first attempt, test creates a snap of the component. But if we would change something, for example title or class name, on next run, test will fail. It takes time to update a snapshot after each change in the component's UI. Let's move to the next test. Here we're using package APIs to test component properties. And instead of creating JSON, we're using root of the element. I will quickly go through those three queries. In the first one, we use find query to get message icon component and check if it contains image element. Next query is more specific version of find. We are looking for a component by using its type, in our case message icon. And in the last one, we are looking for class name property to check whether it shows correct title. And you see that those APIs require from us additional filtering. We start from the node to look for properties. This approach is low level today. Enzyme is another popular library for testing React components, which uses shallow rendering. If in case of test renderer, we could go through children of the component, shallow renderer doesn't do the same. With Enzyme, testing is different. Shallow testing renders a component one level deep without getting its instantiated relatives. It simplifies the way we get methods of the component, but complicates testing of users' behavior. Instead of actually rendering components and calling its children, Shallow just looks at the properties that would be applied to elements created by shallowly rendered component. In this example, we check whether text value of the first button out of multiple ones switches after being selected. We will see how accessing elements looks with shallow rendering. And you can already know that to access only one element, we should use a long path of methods. We start from looking for action buttons and finding needed element. As we have multiple buttons, we should use add method to get the first one. And last step is to get text value of the children. How do you feel about this journey? It took time to get only one component's property. And finally, we simulate the state, doing it directly with the setState method. Such approach feels wrong because users don't do like that. In the next example, we test if filtering by search and tag values matches the output. This will show how we can simulate events with the Enzyme library. First of all, we take our time to create an environment. In this case, it's not enough just to use shallow. We start test from creating new state by updating search query with the tag selection. After that, we directly call an instance getData to get the new state. And last step is to check if the received data is appropriate to our expectations. But there is some magic happening here. If we disable an input, test will pass anyway. As I said before, this happens because shallow rendering is focused on the implementation part more than on real users' behavior.
And late in 2018, a new library emerged called React Testing Library, created by Kent C. Dodds, a well-known educator and creator in JS ecosystem. The library is built on top of a set of helpers to query document object model, otherwise DOM. They started to form a a family of libraries called testing library, soon adding solutions for Angular, Vue, Cypress, and more. RTL, short for React Testing Library, quickly gained popularity because of not so novel idea wrapped into a nicely prepared package. The idea was to avoid implementation details and testing those, and focus on testing UI exactly as users would use it, and provide developers with tools to help them achieve those goals. The idea was phrased into a guiding principle: the more your tests resemble the way your software is used, the more confidence they can give you. And it determines everything in testing library universe. Testing library tries to only expose methods and utilities that encourage you to write tests that closely resemble how your apps are used. Utilities included in the library are based on the following guiding principles: encourage dealing with DOM nodes rather than component instances. It should be generally useful for testing an application components in the way the user would use it. And utility implementations and APIs should be simple and flexible. So how do you use a testing library to test some React code? Let's see an example. Here we have a React component called fetch. It has some internal state, some logic to fetch greetings with Axios library and dispatch success or error when appropriate. It renders a button displaying load greeting or OK, and a greeting or an error text returned from the server. First, we need to import stuff and dependencies like React, mocks for our APIs, using MSW library in this case, testing library helpers, custom matchers for Jest, and the component to test. We usually need some mocks as well, so now is the time to set up. We mock the server with appropriate responses to our requests, and then inside the test we can declare what we expect from the server to return. In this case, an error with status 500 when calling getGreeting. And finally, a test. We call the render function from RTL and pass it our fetch React element with some props in it. Then we click on the button, same as the user would do, using Fire Event API. But how do we find a button? Using the getByText query, which is a screen helper. And what's a screen? It reflects a current browser document we rendered to. Once we clicked, we expect some async actions to happen, which we were mocking earlier. How do we wait for it to finish? Let's think about our users. They don't know if there's a server call or not. They just expect the heading to show up and show some text after they click a button. So we wait for a heading to show up. We use a getByRole screen helper to find a heading in our current context. Once it shows up, the waitFor function will resolve and let us through. We then assert whether the heading has a text content of hello there, and we make sure that the button is disabled. The toHave content and toHave attribute are custom Jest matchers from a package we just imported earlier. And that's how we write tests in RTL. We think as our user would use the component and use some various queries and matchers to assert on the visible outcome. Notice how we don't care about how fetch component does things underneath. We only care about the browser document being updated appropriately, which reflects what user eventually see on their screens. Now that we've seen a small example, it should be easier to wrap our heads around the API. We have the most important render function, which is responsible for rendering our tested component to the DOM and exposing helpful queries in 3 variants. The variants are get, query, and find. Get is synchronous and throws if it doesn't find anything. Query, on the other hand, will return a null instead of throwing. And find will asynchronously wait for the query to resolve, timeout, or reject. We can query our DOM by various properties and attributes like text or ARIA roles. We can fire event, which simulates user events. Wait for helpers are for imperatively waiting for something to happen asynchronously. And get queries for element helps us scope our queries to certain DOM nodes.
We already know that React testing library and alike ones are a step forward in testing React and other web frameworks with JavaScript. React Native is mostly JavaScript, so maybe it's possible to create a testing library for it somehow. There was only a handful of challenges to tackle before we would have an equivalent of React testing library for React Native. Apart from the library being relatively new and moving fast with features, the biggest issue was React Native not actually being run in a browser that has DOM, but in a custom JavaScript environment. We couldn't really reuse reactive testing library. Because of that, it is required DOM to operate in. As developers, we tend to think about JavaScript as a language that only runs in a browser and has an access to a variety of web APIs built in. It's not quite correct way thinking about it, because browsers are only one of many places that JavaScript language can run in. We call those places runtime environments. If you look at the ECMAScript, you won't see any web APIs described there, not even timers. It's up to organizations like V3C, WhatWG, and browser vendors to specify this. JavaScript can run in other environments, like on server with Node.js or recently published Deno. It can run in a hybrid of browser and server using Electron. It can also run on mobile devices without a browser in a React Native JS thread. Let's explore some qualities of React Native JS runtime and how it differs from the web. React Native typically executes JavaScript using one of these JS engines: JavaScript Core, Hermes, or V8, on a dedicated thread spawned next to the UI thread of your mobile application. To make an environment closer to the web development, React Native runtime injects a bunch of APIs into the global namespace. Global object with the window and self-aliases, timers, which are WhatWG spec, not from ECMAScript, some web APIs like XHR, Alert, and Navigator, React Native specific APIs for performance monitoring, exceptions handling, bridge, and more. And other biggest difference, no document, which means no DOM and all related APIs. Now that we know the differences, we can take a look at JS preset exported from React Native repository. Among others, it has a reference to testEnvironment being Node. This is a way to tell just in which environment to run our JavaScript tests in. Pretty neat, huh? Jest ships with Node for Node.js and JS DOM for browser-like environment with DOM by default. But you can also come up with a custom one if you like. Developers behind React Native figure out that the closest environment to run our tests in is Node. It's also the fastest one, by the way. Side note, if you ever used Enzyme, you may have used JS DOM to run your React Native tests, but it was a hack to work around Enzyme's reliance on web and React DOM. It also resulted in a huge maintenance burden on Enzyme community to mocks up to date. Because of that, Enzyme was very slow to catch up with React Native core development. Thankfully, React doesn't care about where it runs as long as it's a JavaScript environment. The core team provided us with a custom renderer for test purposes to be run in Node.js. We already know that its API is quite cumbersome, but maybe we could address it in a testing library API.
Well, it turned out we could. So behold, the React Native testing library. An initial implementation of the testing library API for React Native. Kinda. Our initial idea and the principles we started from was creating a better testing experience for one of our clients, and to make it easy to migrate off of Enzyme test that we were using at the time. And we also wanted to render our components deeply instead of using shallow. We decided to go with a thin layer on top of React Test Renderer and wrap it in a React testing library-like API, because we felt it was cool. The thin keyword was pretty important here. We already maintain a bunch of other libraries and wanted this one to be as little time-consuming as possible. Once we were happy with the results and how the things shaped up, we started considering publishing the library to NPM. The API was inspired by early versions of React Testing Library. You can notice some familiar exports like render, for example, returning queries and in different variants like get and query. It also rendered update and unmount functions to help with development. There's no find queries because they didn't exist back then. They were introduced 5 months later. Initially, we also exported some other helpers like shallow for shallow rendering, which we added for snapshots. Debug, which then moved to the render output, and flash microtask queue, which was eventually replaced by wait for. What's important in this picture is that even in the first release, we diverged from testing library principles that forbid shallow rendering or some dangerous queries like getting by component type or name or props, revealing implementation details not visible to the users. We introduced these, however, because one of our principles was to be able to migrate off of Enzyme at as low cost as possible. Here is an example of how one could test their React Native components with early versions of the library. We rendered questions board component deeply, regardless it's a class or a function, and imperatively called onChangeText prop to change the text of an input, and then call onPress to submit the form. We didn't implement fire event just yet. Then we check if a verify questions function was called with proper arguments. Today we would write this example a bit differently because we have fire event API. We would also use accessibility queries instead of grabbing components by their internal name. But that's how it was. Already a big improvement over Enzyme because we had deep rendering, there was no difference testing class or function components, and whether they were wrapped in higher order components or not. We didn't mangle with internal state. It felt great. If you ever built an open source library, you probably went with MIT or one of BSD licenses and was done with it, since you were the only creator. At least that was my experience. But not this time. Starting a library from the client's code base on behalf of your employer meant nothing else that the intellectual property of the source code belongs to both parties involved in the project, CodeStack and the client. This turned out okay in the long term, but had its downs at early stages of the project, when some decisions were dependent on both parties, and we had to wait for legal departments to agree on certain matters. Interesting experience, wouldn't recommend. We were quite happy with how the library turned out, so we started to promote it in React Native community, write guides and articles. This resulted in a nice and steady adoption and was appreciated by the users. We were adding new features and started identifying gaps that started to accumulate between React Native and React Testing Library. We've also invested a bit of our time in the documentation. And then, after 6 months of our initial release, a new library comes out of the blue. It's named Native Testing Library. It's the first time we hear about it. It aims to be a proper testing library for React Native because RNTL was, well, not so close to their guiding principles, and it has almost the same API and built on React Test Renderer. Sounds familiar? You can imagine how confused we were the first time we heard of the library. Nevertheless, you could tell that the developer behind native testing library, Brandon Carroll, put a lot of effort into creating it. From the very beginning, their docs feature a fully fledged website with guides, examples, even cheat sheets. We know exactly how much work is it to create such a resource, and we're nothing but admiring it. It gave us a nudge to improve our documentation as well. Why was it necessary to create a new library according to its creator? RNTL didn't feel like a part of testing library family. Some APIs had slight differences. Brandon wanted testing library tests to pass using React Native implementation. It was also possible with our library to grab non-host components which expose implementation details of the components that we tested, which were not visible to the users. And RNTL also had a shallow helper, even though not widely used. As you can imagine, we had private conversations between us three, me, Kent, and Brandon. We connected through Twitter to discuss how we can push the situation forward. It was a tough conversation to have, as both parties had some valid points. As some of you already know from the past, we eventually ended up having two libraries living side by side without interfering each other. The negotiations failed. So why we eventually ended up with two libraries instead of merging into one? First and foremost, Brandon, the creator of Untitled, didn't reach out to us for collaboration. He assumed it would be faster to create a new library for his team use case because he was short on time. That's really unfortunate because we'd happily accept help to push the library towards better compatibility with other testing libraries. Additionally, we were guided by different principles, which we outlined earlier. RNTL wanted to be more generic library and target React VR and any React that was not rendering to DOM, really. It turned out that we never actually needed such a use case, but we're still open to add support. After discussions with Brandon, we couldn't agree on certain implementation details of our libraries, which would block potential merging as well. We already had a base of thousands of users, and it would be challenging to change APIs without breaking everybody. And last, RNTL was a library created by CallStack, and it was not in the business interest to just throw away the work we did partially for our client and keep maintaining. So in the end, nobody was to blame for this situation. We couldn't agree on fundamental matters important for each of us, and eventually the negotiations had to break. It's sad in retrospect because it was the community that hurt the most. But it was the best we could do at the time, provided the circumstances. The best we could do now is moving RNTL in the direction of testing library principles. We couldn't agree to merge both libraries, so Kent figured out that he'll go with one of the library that's not the more popular, but closest to the testing library principles. The NTL became an official testing library for React Native. I can't blame him for that. It was a hard decision, and NTL was really following the guidelines. As you probably remember or can imagine, soon after, people started to get confused on why is it like that. It wasn't clear for developers that we ended up with two libraries, and they wanted answers why it happened.
So we did the best we could do. At the time, kept on following a path to slowly deprecate dangerous APIs and make RNTL compatible with testing library ecosystem. That's how we ended up with version 2. our biggest and most important release to date. So what is new in second version of React Native testing library? We decided to remove shallow rendering because this way of rendering React components is usually not a good idea. We are now automatically calling cleanup after each test. Also, a previous version of getByTestID had a bug, which resulted in finding more test IDs than there were in the native key hierarchy. Your wait_for and findBy calls are now automatically wrapped in act, which helps to avoid readed act warning in tests involving asynchronous state mutation, for example, simulating page data from API or using animations. Also, we migrated our documentation to use DocOS version 2, which comes with a refreshed design, improved accessibility, and theme support. Check it out after the talk. New APIs within Helper and findBy queries. Within enables you to perform queries scoped to given element and its children, mainly used for querying list of repeated items or screens. findBy queries are simple, yet useful combination of wait_for and getBy queries. Useful when you want to wait for some UI element to appear. And also, some additional changes were provided for migration, which need to be mentioned too. We removed global debug function. Now debug is returned from render, and it's all you need. By name, queries have been removed after deprecation for more than a year now. By type and by props queries has been prefixed with unsafe. By the way, those functions are not planned for removal in future versions, but their usage is discouraged. In the first version, getByTestID and queryByTestID could return non-native instances, which was a serious bug. In the second version, we fixed this inconsistency. We have deprecated Flash microtasks queue and plan to remove it in the next major. Nevertheless, we have better alternatives available for you to write async tests like find queries and wait for helper. We like to say that we care about users and we mean it. To show how much we put great efforts into creating a migration strategy for those upgrading from the first version. We have carefully planned this release for months and smoothed the rough edges of migration, even before releasing the next major version. For everything else, we prepared a thorough migration guide available on our documentation. Complementary to the guide, we have put some warnings around the deprecated or remove functionality to alert users that didn't see that things have changed.
And soon after the V2 release, Kent approached me with this message on Twitter. It's from our private conversation where he's apologizing for the situation that have arisen since releasing the native testing library and reflecting on how we could have done better at collaborating with each other. He mentions that the official library lacks maintenance, while we did a great job maintaining ours. It's a real breakthrough in the communication between the libraries. He immediately offers deprecating the existing testing library for React Native and promote React Native testing library to be an official one by changing its name. What a fantastic message, because this means we're merging two libraries, putting an end to the confusion and doubts among members of testing library and React Native communities. Based on requests from Kent, we both agreed to the following terms and conditions. We deprecate and archive native testing library, rename React Native testing library to @testing_library/React Native, keep source code and documentation under call stack, and create a migration strategy for both libraries. And of course, we created a migration guide, this time in two versions, one for RNTL users and one for NTL users. We bumped both libraries to V6 to make sure they're even and deprecate the React Native testing library package on NPM. For our existing users, migrating was a matter of renaming the library and one of existing functions. For native testing library users, we've prepared a list of differences and how to migrate to a new library. Prior to releasing V7, we've also made sure to smooth out the rough edges by adding some missing features to V2 of RNTL. Please let us know about the experience when upgrading the library from one to another. We are still identifying small differences and are happy to resolve any issues that arrive. You can hit us on GitHub, Twitter, or Discord under this link. After almost 2 years with the library, we learned some important lessons. Always focus on your users. This is the most important asset your library has, provided it has any. After all, we ship code for somebody to use it. If you believe in your product, keep calm and keep moving. No matter what others do, as long as you keep your users happy. Ease of maintenance is vital to library survival. RNTL is alive today because we don't need to keep up with React Native development thanks to the thin layer on top of stable tools like React and React Test Renderer. Business and open source are mutually beneficial. As a company, ColdStack provides developers like me time to develop open source libraries like RNTL. In return, they get recognition and respect from the community they thrive in. But be aware that businesses have their interests. Thank you all for listening. We hope you enjoyed this journey back to 2018 and learned that behind every project, big or small, there are real people. Have a great virtual React Native EU experience, you all.